So in order to have the robot not cost like hundreds of thousands of dollars, in order to make it cost like $10,000 or $20,000.
Elon Musk wants Optimus to be affordable for the masses. But first, Tesla may sell it at $60,000 to limit demand and perfect production. Once robots start building robots, the price could crash to $10,000. What impact will Tesla's pricing strategy have on the future of the robotics industry? Before we begin, please help us reach 12,000 subscribers. It will be a huge motivation for us to continue bringing you great episodes about Tesla Bot, Tesla EVs, and the latest news. How will the price of the Tesla Bot decrease as mass production scales up? Will the Tesla Bot truly become a mass market product priced under $20,000, as Elon Musk once claimed? This isn't just a futuristic question, it's a very real economic and engineering challenge. In the still nascent humanoid robot industry, most current products are priced from tens to hundreds of thousands of dollars. Boston Dynamics has never commercialized the Atlas robot, while Figure AI has priced the Figure 01 between $70,000 and $100,000 for enterprise use. In such a market, Elon Musk boldly asserts that Optimus could one day cost less than a compact car, even targeting below $20,000 in the near future. It sounds ambitious, but if we look at how Tesla approached electric cars, particularly the Model 3, and soon the Model 2, this isn't an impossible leap. At the heart of this price-cutting strategy lies one key factor: production scale. In industry, there's a well-known rule: the more you make, the less each unit costs. This is called the learning curve. Tesla applied this principle rigorously in EV manufacturing, slashing battery costs from over $150 per kilowatt-hour down to nearly $100 per kilowatt-hour within just a few years. For Optimus, Elon Musk has confirmed that the company is producing the first batch of 10,000 robots in the US. This is the starting point of the learning curve, a first batch that allows Tesla to build, iterate, and optimize, eventually moving toward producing 100,000 or even 1 million units annually. So the question is, does Tesla have the tools to make that happen? The answer lies in Tesla's existing ecosystem. Unlike other robotics startups starting from scratch, Tesla already owns a massive tech arsenal from its EV business: LFP batteries, self-driving cameras, FSD chips, electric motors, wiring systems, and even a global production network. What has already been mass-produced for cars can now be repackaged and reused in Optimus. It's not just the hardware that's being reused. Tesla is also applying its minimalist design philosophy. As Elon Musk once said, "The best part is no part." Optimus Gen 3 currently weighs around 110 pounds, nearly half the weight of Boston Dynamics' Atlas, thanks to the elimination of unnecessary components, optimized actuators, and a restructured mechanical frame. A lighter robot means smaller batteries, lower energy consumption, and most importantly, easier production. Imagine if a robot needs only 100 parts instead of 300. How much faster could it be assembled? And when production speed increases, costs drop again. It's the same loop Tesla leveraged with the Model Y and GigaPress. Even more intriguing, Tesla is going one step further: robots building robots. Musk hinted that in the future, Optimus will assist in its own assembly line, inspecting parts, packaging, even supporting human technicians. A self-replicating robot model, if successful, could generate a scaling effect no company has ever achieved. This could explain why Tesla dares to bet on producing millions of units per year, a goal many still find hard to believe. Another smart move Tesla might apply is a subscription or leasing model. Instead of selling a robot for a high upfront price, they could lease Optimus for a few $100s a month, recouping costs gradually while keeping production at scale. This model has already succeeded in the software industry, and if executed well, could bring Tesla Bot into ordinary households, not just large enterprises. That said, all of this still needs one thing: time. No one can bring the price of Optimus under $20,000 in just the first year or two. In reality, the first version of Tesla Bot will likely be sold for around $60,000, mostly to industrial and logistics partners. But if Tesla continues expanding its production lines, refining the design, leveraging robots to build robots, and stimulating demand through leasing, then slashing the price to 1/3 is entirely feasible. In the end, it's not just about lowering the price, it's about scaling the solution so that this robot can serve every sector and every user, from factories and hospitals to everyday households. And if we look back at the journey from Model S to Model 3, it's fair to say Tesla has done it once with electric cars, and now they're trying to do it again with humanoid robots. Once again, please help us reach 12,000 subscribers. This is important for us to stay motivated. Thank you. Why might Tesla release multiple versions of Optimus at different price points? Tesla is fully capable of launching multiple versions of the Optimus robot tailored to different customer segments in the US, a strategic, streamlined, and highly practical move. Instead of placing all expectations on a single model, Tesla could segment the robot lineup by user needs, optimizing both performance and cost for different living and working environments. This is not just a way to accelerate commercialization. It is the most viable path to making Optimus a mainstream product in the domestic market. At the top tier would be Optimus Pro, designed specifically for industrial zones, automated warehouses, or large-scale manufacturing facilities across states like Texas, Ohio, or the Midwest. This version would handle repetitive, labor-intensive tasks such as loading goods, assembling parts, or inspecting workflows. With the ability to lift 50 to 60 pounds per arm, a frame made of steel or high-strength alloy, robust actuators, and a battery capable of 8 hours of continuous operation, Optimus Pro is built to be an untiring robotic worker. The projected price would range from $60,000 to $75,000, a reasonable figure compared to the cost of hiring full-time labor in the US for 1 to 2 years, not including insurance or shift premiums. On the opposite end, Optimus Lite would be a stripped-down version aimed at the general public, specifically middle-class families in the US, where priorities are convenience, safety, and affordability. This robot doesn't need to lift heavy loads or run continuously. It just needs to handle simple household tasks such as bringing water, picking up objects, carrying laundry, opening doors, or turning lights on and off. By removing high-powered motors, using lighter materials, and simplifying software, Tesla could price Optimus Lite between $15,000 and $20,000, on par with or even cheaper than a sedan in the US. Especially if Tesla applies a leasing model similar to the Model 3. Users could bring home a robotic assistant for just $300 to $400 per month. However, the most crucial segment in the US may be healthcare and elder care, where labor shortages or worsening and caregiver costs continue to rise. Optimus Care could be a game-changing support solution for nursing homes, medical centers, or even private residences. Focused on safety, smooth movement, and natural English language interaction, this version could detect critical situations such as falls, extended immobility, or irregular breathing patterns. If equipped with medical sensors, emotional response audio, and a soothing voice interface, Optimus Care could retail for $25,000 to $30,000, significantly cheaper than full-time live-in care, which often exceeds $5,000 per month in states like California or New York. 3 versions with 3 distinct directions, yet all share the same hardware foundation, operating system, and over-the-air update capabilities. This is a competitive edge only Tesla holds. Thanks to a modular design, a single Optimus frame could be configured into Lite, Care, or Pro, depending on the customer's budget and intended use. It is a remarkably efficient way to control pricing, simplify production lines, and offer a unified user experience, much like how Apple builds a seamless ecosystem from iPhone to MacBook. Rather than dreaming of a single, all-in-one robot, Tesla may realize the robotic future through diversity and specialization. A $20,000 robot may grab headlines, but a product lineup ranging from $15,000 to $75,000, serving the right people with the right capabilities, is the true key to bringing Optimus into every home, every factory, and every medical center across the US. How is Tesla using high initial pricing of the bot to control demand? From the very beginning, Tesla's announcement of an estimated $20,000 price tag for Optimus shocked the global tech community. However, anyone who has followed Elon Musk's product launch strategies knows that this figure isn't intended for immediate sales, but rather as a declaration of intent. In reality, Tesla is highly likely to set a high initial price, not only because production costs are still expensive, but also for clear strategic goals: to control demand, prevent overloading the production line, and most importantly, position Optimus as a premium product, much like they did with the Model S and Roadster. Tesla is currently in the early stage of humanoid robot production, and the volume for the first year, according to Elon Musk, might only reach 10,000 units at the US factory. With such limited quantity, setting a low price would cause demand to far exceed supply, leading to order backlogs, supply chain issues, and a negative customer experience. The lesson from canceling hundreds of thousands of Cybertruck pre-orders is still fresh. Instead, Tesla may choose to price Optimus Gen 3 above $40,000, $60,000 during the first 2 years, targeting strategic customers such as large enterprises, research institutions, or healthcare organizations, entities willing to pay a premium and provide the real-world data needed for Tesla to refine the software. A high initial price also plays a key role in crafting Optimus's premium image. In the US, where brand prestige and exclusivity carry weight, a costly technology product does not deter interest, but rather reinforces the perception of being a cutting-edge pioneer. Just as the Model S paved the way for the Model 3, Optimus Gen 3, with its high price, will establish itself as the most advanced robot, available only to early adopters. The early adopter mindset in America is strong. Many will pay double to be among the first to own new technology, and Elon Musk knows this better than anyone. Furthermore, an elevated price in the initial stage allows Tesla the flexibility to gradually adjust downward over time. As production scales up, from a few thousand to hundreds of thousands of robots per year, and unit costs fall thanks to economies of scale, Tesla could reduce the price to around $25,000 before finally reaching the officially stated $20,000 target. This is a familiar strategy thread through Tesla's EV line. The Model S debuted at $80,000, followed by the $35,000 Model 3, and now the upcoming sub-$25,000 Model 2. It is the same technological base deployed in stages to align with actual production capacity. On the other hand, a high entry price is also a way to test the US market's readiness for humanoid robots. Are enterprises and individuals truly willing to pay $60,000 for a mobile AI assistant when the average yearly salary for a full-time American worker is about $50,000? If the answer is yes, even when rental options might cost $1,500, $2,000 per month, Tesla would receive clear validation to ramp up production quickly. If initial demand is low, they can still adjust without facing significant losses. Finally, starting with a high price helps Tesla to reclaim R&D spending early, spending that has spanned many years and involved hundreds of millions of dollars in AI, robotics, mechanical, design, operating systems, and in-house tooling. In the early stages, each Optimus sold may not produce large profits, but with a high price, Tesla at least avoids losses and builds the financial foundation needed to improve the next generation. After Elon Musk's cryptic tweet just left the Tesla design studio, there will be an epic and shocking demonstration by the end of this year. Speculation has grown rapidly. Several sources suggest that the new version has been trained to perform over 500 additional tasks, ranging from manufacturing and logistics to home assistance. So, is Optimus now ready to take on real-world jobs, and if so, what might that actually look like? Before we begin, please help us reach 12,000 subscribers. It will be a huge motivation for us to continue bringing you great episodes about Tesla Bot, Tesla EVs, and the latest news. How is Optimus 2.5 different from Tesla's previous robot versions? When Elon Musk declared, "That's Optimus 2.5, he wasn't merely naming a new robot version. He was signaling a clear milestone in Tesla's humanoid robot development. The use of 2.5 implies that Tesla is positioned between two major stages, having just moved past the technical testing phase of Gen 2 and nearing the commercialization target of Gen 3. In Tesla's product ecosystem, versions marked with .5 often indicate experimental intermediates that are stable enough for large-scale real-world testing. This approach was previously seen with Starship prototypes from SN5 to SN15 and temporary development phases of the Model S Plaid Plus. With Optimus 2.5, Elon Musk is implicitly confirming that Tesla has built a robot stable enough for real-world production environments, though not yet meeting the human-like benchmark he envisions for Gen 3. Specifically, Optimus 2.5 was introduced with several impressive specifications: a weight of just 110 pounds, lighter than Figure 01 at 150 pounds, and Boston Dynamics Atlas at over 176 pounds. It includes 28 actuators entirely developed by Tesla, enabling smoother movements in joints such as arms, legs, neck, hips, and fingers. The robot can walk bipedally, maintain balance in place, rotate, step forward, and perform basic tasks like picking up small objects, sorting, and folding. Most notably, Tesla has integrated the FSD processor, originally designed for autonomous driving, into Optimus's central control system. This dramatically improves reaction speed, real-time data processing, and intelligent motion learning. The robot's response latency for some basic tasks is reported to be under 10 milliseconds, a rarity among current commercial humanoid robots. However, the decision not to label this version as Optimus Gen 3 reflects Tesla's strategic caution. According to Elon Musk, the ultimate goal is a robot with agility roughly equal to an agile human, meaning it must move, react, and adapt as flexibly as a swift person. This requires not only walking but also climbing stairs, smoothly avoiding obstacles, handling unexpected situations, and even standing back up after a fall. Meeting these demands requires extremely low reaction times, around 300 milliseconds, advanced dynamic prediction, and precise force control with the environment, none of which current commercial robots have fully achieved. Even Boston Dynamics, whose Atlas demonstrates impressive jumping and climbing routines, has yet to commercialize it widely or enable real-time AI autonomy in the way Tesla intends. Thus, pausing at Optimus 2.5 is a wise move. Rather than rushing to Gen 3 with high expectations and high risks, Tesla is opting for broad internal testing with version 2.5. This is a learn-by-doing strategy, deploying Optimus 2.5 across its factories to perform real tasks while collecting data to train the AI and refine the hardware based on real-world feedback. It also allows Tesla to establish its mass production process early. According to official statements, the company plans to build the first 10,000 Optimus units at Giga, Texas, the same site that produces the Model Y and Cybertruck. This means Tesla is not only building robots, but also building the robot assembly lines, something rare in today's robotics industry. In addition to technical and strategic benefits, Optimus 2.5 delivers a major communication impact. While competitors like Figure AI or 1X are still showcasing prototypes, Tesla is already deploying thousands of robots internally and preparing for large-scale production. This sends a clear message that Tesla is leading, not just in technology, but in execution speed and commercialization readiness. With full control over its supply chain, from software and AI chips to manufacturing plants, Tesla holds an unmatched advantage. This reinforces investor confidence in the company's robot ambitions. Elon Musk has emphasized that the economic value of Optimus could surpass that of electric vehicles, since most jobs globally are still manual labor, an area robots could largely replace if designed to be intelligent, affordable, and durable enough. In summary, Optimus 2.5 represents a pivotal upgrade, not just in technology but in deployment strategy. It is the bridge between R&D and large-scale production. Through real-world testing, AI training with real data, and simultaneous factory build-out, Tesla is laying a solid foundation for Gen 3, where humanoid robots will not only move like real humans, but also be ready for market launch at a shocking price point under $20,000. As the entire humanoid robot industry still struggles with prototypes and high costs, Optimus 2.5 positions Tesla as the front-runner in the next-generation automation revolution. Once again, please help us reach 12,000 subscribers. This is important for us to stay motivated. Thank you. Why does Elon Musk believe Tesla can build a Gen 3 robot with human-level agility? One of Elon Musk's most attention-grabbing statements recently was his assertion that the upcoming Optimus Gen 3 will possess agility roughly equal to an agile human, a phrase that can be understood as having flexibility equivalent to a healthy and nimble person. This is not just an ambitious technical target. It marks a clear dividing line between basic assistive robots and robots truly capable of replacing humans in tasks requiring quick reflexes, flexible problem-solving, and sustained operation in dynamic environments. By deliberately emphasizing the word agile instead of strong or intelligent, Musk signaled that Tesla has moved past the stage of focusing solely on mechanical strength and is now tackling a far more complex challenge, combining speed, precision, flexibility, and stability into a single robotic system. Agility in robotics is not merely the ability to perform fast movements. It requires the ability to predict the next motion, shift body posture in an instant, and react to unpredictable environments. In the robotics world, this represents one of the highest hurdles. For example, when a person suddenly encounters a slippery surface or an obstacle ahead, the brain processes a flood of sensory inputs, balance, pressure, traction, and immediately decides how to adjust, lean the body, lengthen the stride, twist the waist, or bend the knees. All of this happens within a few hundred milliseconds. A robot aiming for similar agility must have high-resolution real-time perception, powerful neural processing to interpret the situation instantly. From a technical standpoint, achieving this level of agility demands seamless integration of three core systems: force, vision, and inertial sensors. Extremely fast deep learning processors and actuators capable of immediate response across wide ranges of motion. On a humanoid robot, especially a biped like Optimus, this challenge becomes even more intense, as everything must operate within limited space, energy, and material durability. For a robot to sidestep a falling object, step back when nudged, or dodge when someone walks in front of it, it needs an AI system capable of real-time motion prediction, trained on millions of real-world scenarios. This also means Gen 3 can't simply be assembled and run. It must be equipped with a deeply trained AI system at a level far beyond what autonomous vehicles require. Tesla holds a unique advantage in this field. Its massive AI infrastructure already supports autopilot and FSD across millions of cars. The Dojo supercomputer, Tesla's in-house design, is also being used to train the neural networks powering the Optimus robot. The major difference is that instead of merely learning to detect lane markings or nearby cars, a humanoid robot must learn millions of human poses, understand how to behave in physical interactions, and adjust its applied force in changing environments such as slippery floors, sloped surfaces, or extreme temperatures. This is why Tesla continues to let its robots practice in real-world settings, something no other robotics company in the world is currently doing at this scale. Beyond software, achieving human-like agility also requires hardware breakthroughs. While the current Optimus Gen 2.5 still relies on a mechanical skeleton with limited feedback and some joints that have speed constraints, Gen 3 may adopt new materials with higher elasticity or actuators with real-time torque sensing. Tesla has previously stated that it is developing a fully Tesla-designed actuator system and continues to improve it to reduce weight, increase responsiveness, and enhance joint precision. These advancements are critical if Optimus is to enter fields like healthcare, elderly assistance, high-speed manufacturing, or any human-facing environment, where even small mistakes can have serious consequences. Another crucial factor is that agility does not come from hardware alone, but also from coordination among body parts. An agile person knows how to rotate using their waist, shift their center of gravity, and redistribute body weight optimally while running, jumping, or changing direction. This requires continuous multi-axis coordination, a massive challenge for bipedal robots. Optimus Gen 3 must learn these movement patterns like an athlete, not only maintaining balance but optimizing posture and kinetic energy through every motion phase. If successful, Tesla won't just create a robot that can work, but a humanoid capable of integrating seamlessly into human environments without appearing robotic, stiff, or awkward. Most importantly, the goal of agility equal to an agile human represents Tesla's long-term strategic vision, putting robots into spaces where only humans have previously been effective: hospitals, nursing homes, restaurants, hotels, and even private homes. It signals that Tesla isn't just building robots for heavy industry, but aims to create multi-purpose, socially capable robots that operate long-term in human-centered settings. Once Optimus can move as flexibly as a person, it will overcome the biggest barrier humanoid robots have ever faced: the ability to interact naturally with unstructured environments where there are no predefined scripts, no lane markings, and no physical guides like in factories or parking lots. Tesla's ambition to bring Optimus Gen 3 into the real world isn't just about AI or robotics. It's also a manufacturing challenge on an unprecedented scale. Elon Musk has confirmed that production of Optimus is already underway at Giga, Texas, with a plan to build the first 10,000 units. Unlike traditional robotics companies that treat each robot as a handcrafted prototype, Tesla approaches robot production like it does with electric vehicles: full vertical integration, heavy automation, and continuous design iteration. One of the biggest breakthroughs in Tesla's manufacturing strategy is its ability to co-develop the product and the production line simultaneously. As Optimus 2.5 is being deployed internally in Tesla's factories, engineers are collecting real-world usage data, optimizing hardware based on failures and feedback, and refining the assembly process in parallel. This build-while-learning approach significantly shortens development cycles and ensures that when Gen 3 is ready, Tesla already has a proven, scalable production line. The use of shared components between Optimus and Tesla's EVs, such as actuators, sensors, and the FSD chip, also drastically reduces part complexity and cost. Combined with Tesla's expertise in gigacasting and large-scale battery module production, this allows the robot to be built at a fraction of the cost typical in the robotics industry. Musk's bold claim of a sub-$20,000 price point for Optimus hinges on this exact advantage. Moreover, Tesla is leveraging its experience with software-defined manufacturing, where firmware updates and robot calibration happen digitally on the factory floor. This makes each unit smarter over time, even post-deployment. In short, Tesla isn't just building a robot, it's building a robot factory, which may ultimately become its most disruptive innovation. We appreciate your contributions and hope you will have the most relaxing feelings after watching this video. If you did, please hit the like button and join the Techno Creator family by subscribing to our channel. And don't miss out on any of our awesome videos by hitting the bell icon. We value your feedback and your time. Thank you so much for watching, and we'll see you soon. Until then, stay safe and have fun.